So what we're going to look at now, I just think are some interesting cases. So not really a overlaying theme, just that they can really throw anything at you that they want on these. So you just kind of got to be prepared for anything. So for example, say we had f of x, be consistent at least. Say we had f of x was equal to the square root of x plus 3. And we had g of x was equal to the square root of x minus 2. And they asked us to calculate f, I'll write it over here. If they asked us to calculate f plus g of x and state the domain. Problem like that. All right. So, we're reasonably competent. So we can say, okay, f plus g of x is the same thing as f of x plus g of x. This is actually super straightforward on this problem. F of x is root x plus 3. G of x is root x minus 2. And because I remember that the square root of 3 plus the square root of 6 is not equal to the square root of 9, since I'm not even tempted to do that, I know that I'm in fact done. And this is my answer. Actually, and that's it. X plus 3, root x plus 3, and root x minus 2. But it's the domain part that's going to give me some pause. Because I actually haven't seen any of these problems in a while, but I know that I don't want to divide by 0. And I don't want to take the square root of a negative number. So remember, for the domain, I only want to take the square root, the stuff under the square root sign, to be greater than or equal to 0. All right, so I'm going to pull out the stuff that's inside the square root signs, and I'm going to look at both of them. I want x plus 3 to be greater than or equal to 0. I'm going to use a key word here. And I want x minus 2 to be greater than or equal to 0. All right, you see what we're doing here? See where this is going? If you're not groaning yet, you should be. You should be going, oh, yeah. All right, so I want x plus 3 to be greater than or equal to 0, and I want x minus 2 to be greater than or equal to 0. Remember and shape, what that shape was? It's the pincers. Because the union person, the U, he's like, or, he's like, whatever, one way or the other, shrugging his shoulders, doesn't really care. But remember the and? It was my really goofy, like, little pincer. He's picky, 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 and. You have to satisfy everybody's requirements, so we're going to have to deal with that in a second. Well, we're not quite there yet. We will be soon enough, so let's go ahead and solve this out. So I got x is greater than or equal to negative 3, and x is greater than or equal to 2. So let's go ahead and graph these. So remember how we like to do these. I like to line them up so I can see what's going on. Again, if this is unfamiliar to you, if you don't remember doing this, or you remember but not comfortable doing it, go back and rewatch the lecture. I think that was like 1.6 or 1.7 right at the end of the first chapter that we talked about doing this. So we've got x is greater than or equal to negative 3. We've got x is greater than or equal to 2. And remember, since I'm super picky, super picky, x is greater than negative 3 and x is greater than negative 2. That means I have to meet both requirements. The other way we talked about it was this is the intersection. So if I'm looking to see where they intersect, where they overlap, they don't actually overlap until I get all the way out to here. So that means that my domain only includes 2 to infinity. All right, so this might be a problem that might not be initially obvious, and that's what a lot of these problems are going to do. They're going to be a little funky, and they're going to require some messing with. The idea is they just want you to think about it, honestly. They want you to delve through your memory, delve through all your capabilities, and see how hard of a problem they can get you to solve. Okay. So let's try another one. We'll go f of x is equal to, let's see, 5x plus 3 over x squared minus 9. How's that? And we'll say g of x is x squared minus 9 over 3x minus 5. Something like that, because that's not weird at all. And then f of g is what they want to say. Find f of g of x, f over g of x, and state the domain. Alrighty. Find f over g of x and state the domain. Now, the key thing for this problem here is that as we're going, we always have to be on the lookout for stuff to exclude. So remember, f of g of x is the same thing. I keep saying that. F over g of x is the same thing as f of x over g of x. So here's where I want you to be careful. So we'll go ahead and write it in exactly as it says. And on the bottom, so here's my question. As it stands now, I have 3 fractions, right? I have 3 fractions. I have the blue one, I have the green one, and I have the big honkin' one. So this is my big honkin' fraction. All right, so I'm going to emphasize the division lines we're looking at. This division line, and this division line. So I don't want to divide by 0 on any of these. So I want to exclude, where this is true. I want to exclude where x squared minus 9 is 0. I want to exclude where 3x minus 5 is 0. And I want to exclude where this is 0. All right. I think this is the last one. This last one is a not obvious one. That one's not obvious to me at all. So that's what you want to do when you're looking for the domain on these. So let's solve the domain, then we'll worry about simplifying that fraction later. So let's worry about the domain first. So, because there's just a bazillion ways to do something wrong here. So x squared equals 9. If I take the square root of both sides, I do what here? Stick in a plus or minus. X equals plus or minus 3, right? All right, so we'll keep making progress. That was weird. 3x equals 5. And so x is equal to 5/3. So that's another point I want to exclude. All right. Now this one's actually not going to be as bad as it turns out. I'm just going to write it. Let's see, I'm going to scoot it over a little bit so we have a little bit more room. All right. So how do I want to get rid of that 3x minus 5 on the bottom? Multiply both sides by 3x minus 5. Is that really what I want to do? Yes. Okay, I'm convinced. Okay. So these here will cancel out. 0 times anything is just going to be 0. So I end up with x squared minus 9 equals 0. And that's actually not so bad because that, in fact, turns out to be the same thing that we solved over on this side over here. So we can just jump right down to the answer and say plus or minus 3. So that means we just found the same thing twice, and that's okay. So I want to exclude negative 3. I want to exclude 5/3. And I want to exclude positive 3. Exclude, exclude, and exclude. Everything else is now going to be okay. See where we're going with this? It just takes a little bit of time, and it's not maybe something that you'd initially think about doing. All right, so our domain goes from negative 3 to negative 3, negative 3 to 5/3, 5/3 to 3, and then 3 to infinity. All right, so there's actually 4 sections at work. And I promised we'd go back and finish this. Copy. Paste. Okay. So we need to solve this. So remember when we talked about dividing something? Dividing is the same thing as multiplying by the what? Remember the word? Multiplying by the reciprocal. Multiplying by the reciprocal. So if we want to go 5x plus 3 over that, divided by x squared minus 9 over 3x minus 5, that's the same thing as this. Instead of dividing, we're going to multiply by, this only worked because this was our big division sign here. So this is the same thing as multiplying by the reciprocal. Interesting. That's not that better. Much better, is it? That's kind of a beast. And so if you're going to solve this, honestly, I think I would leave it in factored form. I got 5x plus 3 times 3x minus 5 all over x squared minus 9 times x squared minus 9, which is x squared minus 9 squared. Clearly I meant to do that a little bit different where things would cancel out, but I didn't, so I have to be stuck with the problem that I wrote instead of the problem that I wanted. Just like you're stuck with a problem that's written instead of the one that you want. So, it gives you something to mess with. Sorry about that. Ugly answer. It happens. Ah, well. Okay, let's try something else. We'll do another example. I think another 2, and then we'll be done here. So try, we have, say we have f of x is equal to 2 over x minus 1. And I have g of x is equal to 3 over x. And I want to find f of, well, how is it going to say? It's going to say find f of g of x and state the domain. Okay, so I'm going to find f of g of x, and I know that that's the same thing as f of g of x. So that's the same thing as f of g of x. And I'm going to do the same thing here that I did last time, is I'm going to say, hey, wait a second. I can't divide by 0. So you always have to be on the lookout for things that can go wrong. So I'm going to say, just like you solve these from the inside out, just like you solve these from the inside out, you also construct the domain from the inside out. Okay. Just like you solve these from the inside out, you also construct the domain from the inside out. So what I'm going to do is I'm going to say, okay, 3 over x. I can't divide by 0. So I want to exclude, so let me go ahead and I'm going to focus in on this 3 over x, and I want to exclude where the bottom is equal to 0. I'm going to save this. That's a terrible word. My hands are getting tired. Save for later. Alright, so I'm going to save this for later. But later on, I'm going to exclude x equals 0. Okay? So let's get up to where I can kind of see what's going on. Alright. So, let me actually kind of get rid of this. That's not what I want. Okay. I'm going to get rid of that because it's dumb and it takes up a lot of space. All right. So here we go. So I'm going to keep working now. So I've got f of 3 of x, of 3 over x. So I'm going to use the f function. And everywhere I see an x, I'm going to put 3 of x. So I have 2 over 3 of x minus 1. All right. Now I've already taken care of that 3 of x. So let's see. I'm going to move this guy too. What are you doing there? So I've got f of x, or f of 3 of x is 2 over 3 of x minus 1. And now again, I've got the issue where I have to say, you know, hey, wait, I can't divide by 0. And this is why I did this, because I thought it'd be easier to see if I organized stuff like this instead. All right, so I'm going to focus now on 3 over x minus 1, or actually the whole thing. I'm going to focus on 2 over 3 over x minus 1. I'm going to say that this thing on the bottom, I'm going to exclude and say that this can't be 0. Whatever I get from there, I can't include that. I have to exclude that. Go in here, solve for x, multiply both sides by x, and get 3 equals x, or x equals 3. So I want to exclude x equals 3. So now that I've done all that, now I can go ahead and put my domain together. So I'll go ahead and do that. So I'm going to draw my line. I've got 0 and 3. I'm going to exclude 0. I'm going to exclude 3. So I can pull off my domain, which is negative infinity to 0, 0 to 3, and 3 to infinity. Oops. And 3 to infinity. So now I can finish this off. Hopefully a little bit organized in your paper. I think I kind of blew it here at the end. Sorry about that. That's not even the end. That's actually kind of mean. Sorry about that. That was supposed to be an f. F of 3x. So now I can go ahead and simplify this. So if I have 2 over 3 over x minus 1, I got to get the x out of the bottom. So I multiply the top and the bottom by x and get 2x over 3 over x times x is, what's it called? 2 over x, 3 over x times x is, hey, 3, and minus x. And believe it or not, that's your answer. It's totally exhausting, right? Super fun. All right, if you thought that was super fun, I'm going to give you one more and I promise we're done. This is long and exhausting. I know. So, here is like the ultimate brain teaser. He'll say, given this, oh, yeah, we'll go ahead and say that. I think that's how your book does it. I say the cube root of x squared plus 1. We'll say, if this was f of g of x, what would f of x and g of x be? So if this was f of x, what would f of x and g of x be? So what they're trying to get you to do, and I don't know a good way to do it except just to stare at it till it makes sense. What they're trying to get you to do is to recognize how functions can be created from other functions. So what they kind of want you to do is start messing with it and say, well, what function's happening on the inside, what function's happening on the outside? So that's kind of how I do it. I go an inside-outside approach. So I would say, okay, well, I've got something going on inside, and then I have something going on outside. I think I've actually reversed my colors from when I've been doing standard in here. So I have an inside, and I have an outside. And since I know I work my problems from the inside out, you know, I work problems from the inside out. So I'd kind of say, all right, well, that must mean that my inside one must be g of x, and then my outside one must be f of x. You're like, well, I don't have anything to put in the middle. I don't have anything to put on that cube root sign. Well, yeah, you do. You just put x. And really, this is a trial and error thing. The only way to really figure this out is to actually do it. Say, well, what is f of g of x? If this was my function, if I'm right, this should work out. So I'll go stick this in here, x squared plus 1. So that means I'm going to do the f function that I made up here. And everywhere I see an x, my little red x, I'm going to put x squared plus 1. And in fact, that's what I get. So don't beat yourself up on this one. This is more of a challenge problem. If it makes sense to you, great. If not, figure out this one problem for the homework and probably won't see it again. So hope you're having fun. Knock yourselves out.